about an optical system of eye. Optical system of eye accommodation. Human eye is an original optical device borrowing in a section of geometrical optics a special place. It speaks that many optical tools are designed for visual perception of their indications. On the other hand, human eye and animals as a biological system advanced during evolution give some ideas on designing and improvement of optical systems. Look at the picture. Let's consider the structure of an eye. The ear ball has almost a spherical form of diameter in axial direction 24 or 25 millimeters. Eye contains photoconductive and photoperceptible device. Walls of eye consist of three concentric located mediums: external, average, and internal. External medium, sclera, in the forward part of eye. Cornea passes to the transparent convex cornea. Look at the picture. Next, separated from sclera, cornea has the form of a spherical cup of diameter about 12 millimeters. Thickness of cornea is about 1 millimeter. Radius of its curvature is 7 or 8 millimeters. The refractive index is 1.38. To sclera adjoins vascular medium, which internal surface is covered by a layer of the pigmentary cells. Interference of light in eye. The vascular medium in the back part, named bottom of the eye, adjoined retina, containing a photoperceptible device of eye. It consists of the smallest cells, rods, and cones, providing twilight and color vision. In the medium passes to iridescent painted at various people differently and having in the center small round aperture that is known as a pupil. The iris of an eye is the original diaphragm regulating diameter of the pupil from 3 millimeter at bright up to 6-8 millimeter at weak illumination, and by that the light stream getting to the eye. The space between the iris of eye and the cornea, the forward chamber, is filled by the transparent liquid close on optical properties to water. Directly behind the pupil is located the crystalline lens. It is the elastic transparent body having the form of the biconvex lens with refractive index 1.4. Diameter of crystalline lens is 8 or 10 millimeters. Radius of curvature of the forward surface is 10 millimeter and the back is 6 millimeter. Curvature of crystalline lens can change with help of the circular ciliary muscles. All internal cavity of eye is filled by transparent jelly-like liquid, the vitreous body, with a refractive index 1.33. Retina serves as a photoperceptible screen on which turns out the valid and reduced image of a subject considered by eye. Refracting system of eye, the cornea, the moisture of the forward chamber, the crystalline lens, the vitreous body, represents the central optical system with taking place through the geometrical centers of crystalline lens, pupil, and the cornea. For optical system of eye as well as for any optical system, it's possible to specify six cardinal points with which help determine direction of rays of light. It are two main points, H1 and H2. Two central points N1 and 2, and the two focuses F1 and F2. Look this picture, the optical system of eye. Through two main points perpendicularly to optical axis pass two main planes, planes 1 and plane 1 and the plane 2. On identical distance from them, they are focuses. At construction of images, use the following rules. The beam going from a subject through focus and crossing the first main plane on height h from the optical axis leaves the plane 2 on the same distance h from axis and in parallel to it. The beam going from a subject to one central point N1 leaves other central point N2 in parallel the initial direction. Average position of cardinal points in the human eye is defined by results of research of set of people with a normal sight. Both main and both central points in the average eye are located close from each other. In eye, still distinguish the visual axis, which is taking place through the center of crystalline lens and the yellow spot, and determine direction on which the eye has the best sensitivity. The angle between the visual axis is 5 degrees. This angle has a practical value. If it is great, there is an impression of squint. It should be taken into account at determination of distance of center to center of spectacle lenses. The healthy eye adapts to vision of the subject located from it one distance of 10-15 centimeters and up to infinity. This ability of an eye is known as accommodation. Accommodation is the ability of eye to change optical force due to change of curvature of crystalline lens that allows to receive precise images of subjects on retina. When the eye is accommodated for distant vision, both circular and meridional fibers of the ciliary muscles are relaxed. This stretching the zonula which squeezes the elastic lens to a flattened shape. Look this picture. In order to increase the reflective power of the lens when viewing a close object, both sets of fiber of the ciliary muscles contact. Each has the effect of releasing the tension in the zonula, which then allow the lens to be bulb. There is an increase of optical force. Its optical force is D, where R1 and R2 are radiuses of curvature of crystalline lens. Proceeding from the formula of lens, The next expression for D, it allows an increase of D to reduce the distance up to object D small, not changing distance up to the image is F small. As a whole, the optical system of an aperture is the converging lens with a variable focal length. All system of eye is not intense condition. Has optical force, refractive power about 65 diopters. The basic reflection of light occurs in the external surface of cornea on a border with air. Look at this picture. The reflective interfaces of the cornea. Cornea has optical force about 43 diopters. Optical force of crystalline lens is about 20 diopters at vision of the removed subjects. At vision of close subjects, curvature of crystalline length increases and the optical force of eye can reach of 70-75 diopters. It's a limit of accommodation. As an adult person, healthy, at approach of subject to eye up to distance of 25 centimeter accommodation is made without a pressure and due to describe the subject which are taking place in hand. The eye more often accommodated on the distance named is a distance of the best vision or least distance of distinct vision. The minimal distance up to a subject corresponding to the maximal accommodation defines a position of a so-called near point of clear vision. Near point of the eye. Position of near point depend on age of a person. With the year, this distance increases, decreases. For construction of the image of subject on retina of eye and the analysis of the phenomena connected to it is used the reduced or the which is considered is homogeneous spherical lens. Some circuits of the resulted eye rather close amount themselves are offered. The next figure, the eye on Verbitsky, such circuits resulted. Radius R of the forward reflective surface is 6.8 millimeters. Radius R of a sphere is 10.2 millimeters. Length of the axis is 23.4 millimeters and a refractive index 1.4. The optical center of lens is on the distance of 6.8 millimeters from top of the forward refracting surface and main focus F on the distance of 16 millimeters from the optical center. It is assigned to the lens. And in the resulted eye on Vitebsky, the main and the center point for simplification of construction as well as for a thin lens are combined and are in the point, the center of the lens. Construction of the image of a subject in the resulted eye is done by rules for a single thin lens. The subject usually settles down behind the double focal length and the image A1B1 result on the back surface of the reduced eye, the valid, inverted, and reduced. Talk about resolution of eye and defective optical system of eye. The size of the image on the retina depend not only from the size of a subject but also from a distance to eye. It is from the angle under which the subject is seen. Look at this picture. For the characteristic of size of the image on the retina enter concept of the visual angle. It is an angle beta between the beams going from extreme points of the subject through conterminous center point. The size of the image on retina is B small. It's L and beta. It's a product L and beta, where L is a distance between the uniform central point and the retina. L is equal 17 millimeters. The formula is far if the visual angle is small. From the resulted figure, it is easy to establish a connection of size of the subject with the distance big L of capital L. Of subject from the central point of the eye and the visual angle of sight. Capital B is a product capital L and beta. Look at this expression. The B is L, B divided by L. Resolution of eye can be estimated by the minimal visual angle beta minimum under which two next point of a subject are visible separately. This angle finally defined the size of the image on the retina. Within the limit of the yellow spot at good illumination, eye of the person start to perceive 2 points if beta more or equal 1 stroke, and beta minimum, the value at beta minimum is equal 1 stroke. Characterize resolvability of an eye, the maximal visual acuity, and is defined by structure of the retina. Two next points are visible separately if their image get on different receptors. This condition also defines the limit of resolution of eye. At normal vision, the person counts of 25 centimeters to points, taking place from each other on a distance of 17 microns. The size of the image on the retina, this is equal to 5 microns. That correspond to average distance between corners. Therefore, if the image of the point on the retina will borrow smaller distance of 5 microns, these points are not resolved. It is eye of them does not distinguish separately. In medicine, resolution of eye estimate visual acuity. The last, look at this, the last equation. V. For norm of visual acuity is accepted L, and in this case, the least visual angle is equal to one stroke. At infringements, visual acuity in so much time is less than norm. In how many times the least angle of sight is deviation from norm more than 1 minute. If for the patient the minimal angle of sight is equal 4 strokes 4 minutes. T is equal 1 to 4, it's 0.25. Visual acuity is a basic function of eye by which is guided at selection of glasses. Main optical characteristic of eye is represented with a position of back focus concerning of retina. It's known as clinical reflection of eye. Look at this first picture. If the point of focus lays on the retina, the reflection is called emmetropic. If behind the retina, the eye is hypermetropic. If before the retina, the eye is myopic. Only the first reflection provides at rest of accommodation a precise image of far subject on the retina and hence normal vision. The most widespread defect of vision is short-sightedness, myopia, connected with first the lengthened form of the eyeball and less or often with, and second. Excessive optical force of reflecting mediums of eye at this normal form. This sharp image A1 and B1 of far subject is formed in the plane laying a little bit ahead of retina. Such eye does not see distinctly far subject. Accommodation this is useless as it increases excessive for the eyeball optical force of eye even more. For correction of short sightedness is necessary to reduce optical force of the eye by application of glasses with disseminating negative lenses. This image A2B2 on the distant subject turns out on the retina. Continuous lens, the path of beams without the lens is shown by a combination of shaped and continuous lenses shown with the lens. The far sightedness hypermetropia is connected with insufficient reflecting ability of the eye or with the short form of the eyeball. Image A1B1 of the far subject turns out behind of retina. With help of accommodation of eye, in part eliminates this defect. However, limits of accommodation are limited and such eye does not see distinctly close located subjects. Glasses are applied to elimination of far-sightedness with collecting positive lenses which strengthen reflecting ability of eye and provide sharp image A2B2 on the retina. With the eye, there is a change of elastic properties of crystalline lens, and there is a age far sightedness. More seldom there is a defect of vision, astigmatism, which is connected with non-uniform reflection on various meridians planes of eye. This phenomena is caused by defect of the correct spherical form of external surface of the cornea and the crystalline lens. If on such eye falls the bundle of parallel rays instead of one focal point, rays are agglomerated in two segments. Look at the cylindrical and toric lens forms. A segment lays in the focal planes of principal curves. Measure of astigmatism, so-called astigmatism difference, is a difference of reflecting force of two principal curves in diopters. The more astigmatic difference is more distance between horizontal and vertical segments. Significant astigmatism caused distortion of the form of a subject retina, stretching them at length or width. Astigmatism demands a correction of vision also through its dependent kind of clinical reflection and accompanies to ametropia, hypertropia, or myopia more often. If to look on an astigmatic eye in the front and mentally to dissect his biplanes, which are taking place through the pole of cornea, appears that the refractive index of this eye smoothly changes from the biggest value in one of section up to the smallest in the other section, which will be perpendicular to the first. If in such section the reflection remains the constant, it is a correct astigmatism. If for various beams within the limits of the certain section, the reflection appear various, this kind is named wrong astigmatism. Classes can correct only astigmatism. Correction of astigmatism is carried out by cylindrical and spherocylindrical lenses. Two defects of sight also concerned presbyopia or age weakening of accommodation because of loss of elasticity by crystalline lens. For its correction are used positive lenses. A special case is aphakia. It is a condition after extraction of the grown tobid crystalline lens, cataract. There is a far-sightedness of very high degree, demanding correction by strong positive lenses of 8 and 13 diopters. Both eye work for the person as the coordinated system forming a uniform image of the seen subject. Ability to form such image from images of two eyes is known as binocular sight. Simultaneously, a binocular sight allows to estimate remoteness of a medical subject. This ability of eye is called three-dimensional sight. The place is in space where vision lines of two eyes crossed is known as a point of fixed. Enlargement of binocular sight is shown as the squint more often. The squint is a deviation of the visual line of one eye from the joint point of fixing. On the direction of deviation of visual line of the eye distinguish the squint, convergent, missing, and vertical. For correction of the strabism, use prismatic lenses. Look at this picture of this prism. Talk about basis of photometry. Discussion of question of biophysical process of visual perception, demand of knowledge of the basic concept concerning measurement of light values. This circle of question studies photometry, light metry measurement. One of photometric quantities is a light flux, and this first expression phi, light flux phi, which represent A energy of dW, the light wave taking place per unit of time through the given surface. The light flux is measured in lumens, but LM, lumens. The next, light exposure intensity of illumination is a ratio of the light flux to the area of this surface. The next expression is E. Light exposure is measured in lux. Physiological action of light on the person substantially depend on light exposure. At small light exposure and the eye hardly distinguish a fine subject and quickly gets tired. At bit light exposure, light renders harmful action on the retina and execute of nervous system. Therefore, hygienic norm of light exposure of inhabited and industrial rooms are established. For example, in an auditorium at the level of surface of table, light exposure about be 150 lux. In rooms in a hostel is 50 lux, etc. The next characteristic is the light intensity of source. It's I. This expression I is a ratio of the light flux to radius of the solid angle inside which this flux is propagated, where double omega, omega is a solid angle measured in st radians. Light intensity is measured by candela. It is a basic unit in a system of C. The next characteristics, brightness. Brightness, the capital L, is a value numerically equal to the ratio of the light flux inside the solid angle to value of this angle and to the area of the radiating platform, where alpha is the angle between the normal to the surface and the axis of the solid angle. As d phi divided by d omega, it's I. It's a light intensity. Then brightness has this equation, this expression. And now talk about sensitivity of eye for light and color and adaptation. Light getting to the eye is focused with the help of crystalline lens on the layer of photosensitive cells of retina. Photosensitive elements of the retina cones are located in the yellow spot. Rods settle down on edges of yellow spot and on other surface of retina. The number of cones is equal approximately to 7 million and number rods are approximately 130 million. Look at this picture, these cones and these rods. Rods do not distinguish color and responsible for black-white vision or twilight vision. Only the light irritation of cones caused sensation of color and due to presence of cones is carried out daytime sight. Cones are concentrated in the center of the retina because color vision is carried out in a condition of bright illumination at the narrowed pupil, passing light basically on the center part of the retina. Sensitivity of rod is much higher than cones that function only at light exposure more 10 in power minus 2 lux. Whereas rods react to light even at light exposure up to 10 in power minus 6 lux. It is easy to be convinced when it seems to us that all subjects lose their coloring. Perception of light as well as the perception of sound submit to law of Weber-Fechner, according to which the change of force of light sensation is proportional to the logarithm of ratio of intensity of two compared light streams. The photosensitivity of the eye change over wide range due to visual adaptation. It is known that at input in a poorly covered room, in the beginning the person does not distinguish subject and for their distinction needs a certain time. It is transition from daytime vision to twilight vision demands a certain time. This process is known as adaptation. Adaptation is the ability of eye to adapt to various brightnesses. Before full adaptation time of 30, 40 minutes sometimes is necessary. Adaptation allows to eye to function normally in the range of brightness. The brightness uh, 10 in power minus 7 or 10 in power 5 candle divided by meter and square. Researchers have shown that a minimum quantity of light which should fall on the surface of eye for creation of light sensation make from 60 up to 150 photons of yellow-green light. To retina reach even less photons. About 50% is absorbed by crystalline lens, about 4% is reflected from the cornea. This on share of photoreceptors There are some photons from number of the photons falling on the cornea. Recent researchers have shown that threshold of sensitivity of the eye adapt to darkness for yellow-green light makes only 2-3 photons. Photoreceptors will into electric with a coefficient of amplification of 10 in power 5, 10 in power 6. Such big amplification allow even to individual photons to create the nervous impulse and accordingly light sensation. And color sight is caused by corneas. According to theory of Jan Gelmgolds, there are 3 types of corneas with various curves of spectral sensitivity with a maxima of 440, 540 and 590 nanometers. Each kind of corneas creates a sensation only one color, red, green or dark blue. At simultaneous excitation of receptors to the brain enter signals of diffusion of intermediate color. All a variety of color sensation is defined by the parity between number of the pulses sent by excited corneas. The pigment of corneas contains also 11 His retina as well as rhodopsin, but the luminous part of pigment differs. Therefore, pigment of corneas is called idenopsin. They have violet coloring. Every one cone contain only one kind of idenopsin. Absorption of light by idenopsin as well as the case the rhodopsin result to occurrence of potential in corneas. 3-component theory of color vision explains the majority of the effects of physiology and pathology of color vision. At some genetic diseases, synthesis of proteins, idenopsin is broken, therefore color vision is not formed. The person loses ability to distinguish colors. Look at this picture. This illness is known as daltonism. And now, talk about electronic microscopy and fiber optics. And I talk about lenses and path of wave and magnification. A lens is a transmissive optical device that focuses or disperses of a light beam by means of refraction. A simple lens consists of a transparent material, while a compound lens consists of several simple lenses elements. Elements usually arranged along a common axis. Lenses are made from materials such as glass or plastic and are ground and polished or molded to a desired shape. A lens can focus light to form in an image, unlike a prism, which focusing. Devices that similarly focus or disperse wave and radiation other than visible light are also called lenses, such as microwave lenses, electron lenses, acoustic lenses, or explosive lenses. Type of simple lenses. Lenses are classified by the curvature of the two optical surfaces. A lens is biconvex or double convex or just convex if both surfaces are convex. If both faces have the same radius of curvature, the lens is equiconvex. A lens with two concave surface is biconcave or just concave. If one of the surfaces is flat, the lens is a plano-convex or plano-concave, depending on the curvature of the other surface. A lens with one convex and one concave side is a convex, concave, or meniscus. It is this type of lens that is the most commonly used in corrective lenses. If the lens is a biconvex or planar convex, a collimated beam of light passing through the lens converges to a spot of focus behind the lens. In the case, the lens is called a positive or converging lens. For a thin lens in air, the distance from the lens to the spot is the focus length of the lens, which is commonly represented by f in a diagram and equations, and extended hemispherical lens is a special type of plane which the lens curved surface is a full hemisphere and the lens is much thicker than the radius of curvature. If the lens is concave or planar concave, a collimated beam of light passing through the lens is divergent spread. The lens is thus called a negative or diverging lens. This negative. The beam after passing through the lens appears to emanate from a particular point on the axis in front of the lens. For a thin lens in air, the distance from the point to the lens is the focus length through is negative with respect to the focal length of a converging lens. Convex concave meniscus lenses can be either positive or negative, depending on the relative convergence of two surfaces. A negative meniscus lens has a steeper concave surface and is thinner at the center than at the periphery. Conversely, a positive meniscus lens has a steeper convex surface and is thicker at the center than at the periphery. An ideal thin lens with the two surfaces of equal curvature would have zero optical power, meaning that it would neither converge nor diverge light. All real lenses has non-zero thickness, however, which make a real lens with identical curved surfaces slightly positive. To obtain the exactly zero optical power, a meniscus lens must have a slightly unequal curvatures to account for the effect of the lens thickness. A lens is formed by two curved surfaces, or one curved and the second flat surfaces, and a transparent medium like the glass field or exist between the two surfaces. The lens can have any type of curved surface, such as spherical, parabolic, and cylindrical, but we usually talk about or use a spherical lens. That is, when someone tell us about a lens, we generally think of it as a spherical lens, and in the middle there is a transparent medium, so we can also say clearly that there is no reflection of light from both the surfaces. The side from which light enters the lens is called the first surface of the lens, and after refraction from both surfaces. The page from which the light exits the lens is called the second surface. And derivation of thin lens formula. From the thin lens ray tracing methods, we can derive algebraic expression relating quantities such as object distance, focal length, image distance, and magnification. We will call the distance that the object is the left of the lens S, S1 or U. We'll call the distance that the image is to the right of the lens S2. Look at this picture, it is very small. Or V. And the distance of the focal point to either side of the lens is F. Let's also call the head of the object H1 and the head of the image H2. Look at this picture. It's the H1 and the H2. H1, H2. Now we need to use geometry to get a relation between these distances. That is, we'll derive the equation. There are two triangles here. Look at the picture A. That we can make use of one on the left and one on the right. These two triangles are similar. They have the same angles in all their corners. We know that the side all scales in proportion. So we can conclude one information, and that is H2 divided by H1 is equal S2 divided by S1. Angles and make use of them in this picture B. Again, we have two similar triangles, so we can take radius of sides. This expression, we are going after an equation that relates the S1, S2, and F. So we want to eliminate H1 and H2. That's quite easy to do. The first equation is a ratio of the H's, and we can rearrange the second equation to make is the same ratio of H's. Look here, this ratio of H's. Create now just equate this expression with the first expression. Look at this. Now it's a matter of fiddling this around to get the form of equation you ask about. Simplify the right side, dividing out the f. Into this expression. Now divided both sides by S2. They divided by S2 and we get this expression.